solution, I will be creating elephant toothpaste, which is the result of the catalytic decomposition of hydrogen peroxide. To do this, I will combine 3% hydrogen peroxide with food coloring and highly concentrated dish soap before adding potassium iodide to produce the reaction. The chemical equation that represents the reaction is 2H2O2 aqueous yields 2H2O liquid plus O2 gas. The iodine added acts as a catalyst and has no chemical effect on the reaction, and is therefore not included in the overall equation. A catalyst is a substance that speeds up a chemical reaction, but is not consumed by the reaction. It can be recovered chemically unchanged at the end of the reaction. In order for reactants to become products, they must overcome the activation energy of the reaction. Activation energy is the least amount of energy required to activate atoms or molecules to a state in which they can undergo a chemical reaction. A catalyst provides a different route for the reaction with a lower activation energy. Adding a catalyst allows a greater amount of the reactants to become products. Catalysts will not change the equilibrium constant of the reaction, but it will change the rate constant. The rate constant is determined using the Arrhenius equation. The rate constant is equal to the pre-exponential factor times the mathematical quantity of E to the power of the activation energy divided by the gas constant times the temperature in kelvins. As the activation energy goes down, due to the addition of the catalyst, the rate constant will go up. Because of this, the catalyzed rate constant will be significantly greater than the uncatalyzed rate constant. Iodine acting as a catalyst speeds up the decomposition of hydrogen peroxide. A decomposition reaction is where a single compound breaks down into simpler compounds. In this case, hydrogen peroxide breaks down into water and oxygen, as shown in the overall reaction of 2H2O aqueous yields 2H2O liquid plus O2 gas. We will begin the demonstration using 3% hydrogen peroxide, highly concentrated dish soap, potassium iodide, food coloring, an Erlenmeyer flask, a graduated cylinder, and a scoop for the potassium iodide. First, you will pour 50 milliliters of hydrogen peroxide into the graduated cylinder. You will then pour the hydrogen peroxide into the Erlenmeyer flask. Next, you will add 3 to 4 drops of your chosen food coloring. Swirl to mix together the food coloring and hydrogen peroxide. Now you take the highly concentrated dish soap and drip it down the side of the flask in order to create a slight film on top of the solution, being sure to get as much dish soap as you can into the solution. Next, you will take a small scoop of potassium iodide in order to start our reaction. Once the potassium iodide is added, you'll notice a color change on top of the solution, which signifies the start of our reaction.